Hola a tots i totes. Primer de tot, donar moltes gràcies a en Bernat Romagosa, al John Maloney i també a l'equip del City Lab, al José, al Víctor i la Nina, que hem estat aquests dies també treballant en el projecte de microblocs. I ara tocaria en dos espais de Snap i Snap4Arduino que els hem ajuntat en un de sol, perquè aquest any el John Maloney també és amb nosaltres, però a distància, i ens ha preparat una activitat molt interessant que de seguida veureu. Llavors farem això tot junt durant una hora. Primer de tot posarem aquí la presentació on el Gens ens diu hola a tots i a totes. Quan vulgueu podem posar el vídeo, encara tenim el Gens en el xat online. Arreglem un moment l'àudio, el Gens l'heu vist al xat que ens deia hola, el John també, que es veu que s'ha llevat una mica d'hora perquè el seu horari és un altre, i mirem de posar una altra vegada la salutació i així sentirem la veu del Gens.
Això mateix que l'altre dia, està l'splitter posat.
El que veureu amb aquesta activitat que ens ha proposat és una introducció a tota la temàtica de la intel·ligència artificial. El Gens està preparant tota una sèrie d'activitats curriculars per portar-ho a l'escola i veureu que en aquesta activitat ens permet treballar-la des de diferents angles, des de fer una introducció i jugar amb ella, des de veure com es construeixen els algoritmes per treballar-ho, fent-lo sempre des de una forma dinàmica i que es pugui interactuar, com vèiem abans en microblocs, que sigui d'una forma constructiva, des del fer, des del crear, doncs la podem modificant. D'acord? Llavors, l'altra cosa que us voldria dir mentre és que tenim, ara posarem al xat l'adreça, a l'espai Odissea tenim un espai que és els aprenentatges creatius amb Snap, que molts de vosaltres ja esteu subscrits. Posarem l'adreça perquè serà el lloc on ara tot el que veieu, els vídeos, els projectes, els tindreu penjats, i alhora també anirem publicant durant aquesta setmana alguna altra notícia d'altres novetats que volíem compartir amb vosaltres, però que amb el format aquest de temps tampoc tindrem temps de desenvolupar. Per tant, us convido a entrar. Veureu que a l'entrar a l'espai primer us demana una petita validació per indicar-nos la vostra especialitat, nivell educatiu, però és d'inscripció oberta, llavors estareu al corrent de les notícies i també podeu aprofitar els fòrums per fer-nos qualsevol consulta, tant a nosaltres com també al Bernat, el John i el Gens també s'han ofert que qualsevol dubte també per tenir aquest feedback que és necessari per anar construint les propostes educatives. Mentre arreglem el vídeo, aprofito també, ho posarem al xat, o sigui, no us preocupeu, però molts de vosaltres us heu inscrit a l'activitat i per poder certificar-la us posarem l'enllaç, però recordeu que heu d'anar a les meves activitats a la Xtech i, com sempre, allà teniu les vostres activitats i un cop teniu les activitats veureu que teniu un qüestionari que estarà obert durant el cap de setmana, fins dilluns, perquè pugueu omplir-lo, ens podeu fer una mica de retroacció de les coses com les heu vistes vosaltres, i també serà l'eina que utilitzarem per la certificació. Tenim problemes amb el vídeo, però sobretot el que voldria transmetre, ja us ho diu el Gens en l'activitat, és que hi ha moltes maneres d'agafar-la, llavors us convido a jugar amb ella. Veureu que hi ha la construcció des de zero amb Snap i, per tant, els que no heu treballat gaire, potser hi ha alguns aspectes que semblen més difícils, però es pot començar des de qualsevol lloc, és a dir, es pot començar obrint el projecte i jugant amb les propostes que us fa i després aprofundir amb aquells blocs que vosaltres penseu que és d'interès per veure com es fan els dibuixos o com es fan els càlculs. És a dir, hi ha diverses maneres d'aproximar-se que ens poden ajudar a tenir diverses. Doncs ara passarem a veure primer el vídeo on ens diu hola el Jens.
Hi, dear friends from Robolot. I'm so delighted to be talking to you. This is, as I understand, the 20th anniversary of Robolot, and it's actually the 4th consecutive year that I'm honored to be part of the FABA residency. Sadly, the second time this is online, I'm not able to be there. So friends, snappers, it's really great to be at least virtually in touch. I've kind of thought long and hard what I wanted to tell you. And, you know, actually, at this time, I think it's really just about telling stories to each other, about exchanging ideas, and about being together. So rather than a keynote, what I've done is I've recorded a little activity, kind of like a workshop, where I'm inviting you to follow me along to use artificial intelligence and machine learning to animate a story and to maybe animate a greeting card to express yourself computationally in a way that might be surprising and delightful. So the story that I'm going to tell is really just a thank you to all of you. I'm really missing the community over in Olod. I'm missing the friends. I'm missing the friendship. So as I'm looking out of the window, as I'm recording this here in southern Germany, it is raining heavily, and it's actually kind of cold, a little too cold for May. And this has turned into a somewhat strange world. It is the second time in a row that our world seems to be cursed by this COVID virus, and it's kind of keeping us from being together. And the worst part for me is really missing out on the friends, missing out on all the moments together where we've been inspired and delighted by ideas, where there have been these eureka moments of sudden recognition of something that has happened to us. So I'm thinking of this other place where you're now, and I really would love to kind of step into my car, and I'm looking forward to the time when we'll be able to travel again and meet again in person. As right now we're really trying to uphold this online, as the vaccinations are really picking up, we're hoping to be at a place where we can physically meet again, maybe in a couple of months. And so all of you who are now maybe at the slopes of the Garrocha volcano, where in the beautiful town of Olod, this year for the 20th time there is the Robolot conference. I think I'd really like to invite you to play with some of the cool features of Snap, to maybe find out how you can let your mind fly using some cool abstraction techniques that I've prepared for you. And it's actually kind of funny, now that I think about it, I really miss the rain over in Garrocha, over in Olod. I'm wishing you a very happy, insightful, inspiring Robolot conference. Please get in touch, send me an email if there's anything about Snap, anything about the activity that I've recorded for you that you encounter. I'm very much looking forward to hearing from you. Thank you, and enjoy the conference.
Moltíssimes gràcies, Jens. Nosaltres també t'hem trobat a faltar, encara que estem sempre en contacte amb 1000 projectes que estan a mitges, i tot i que la pluja aquesta d'Olot, avui per la finestra veig que surt el sol, per tant jo crec que és un senyal de que sí que ens trobarem aviat. No sé, aquest cotxe que hem d'agafar, si com deia el Toni haurà de ser elèctric, però segur que trobarem les maneres de veure'ns i continuar treballant. I un plaer tenir-te aquí a Olot, ja com deies, per quart any consecutiu. Doncs moltes gràcies, i ara veurem com fer totes aquestes meravelles amb les que jugaves per explicar-nos històries, com les podem construir nosaltres mateixos amb aquesta eina Snap que la gaudim cada dia.
Hi, and welcome from the lab where we make Snap. Today, I would like to show you an activity that's been in the working for a couple of years. It is about making artificial intelligence and machine learning accessible for school courses, for school classes. And it's an activity that we've been showing off at various occasions, and we're finally ready to deep dive and show you how you can build it yourself. The activity that we're talking about is something where we draw, where we sketch shapes and make these come to life. So for example, I am going to sketch a boat, and the program is going to notice that this is a boat and will animate it accordingly. Now this is easy if it only knows one shape, but what if we have different shapes? For example, one thing I'd like to draw now would be a heart shape, and now the program should notice that it's a heart and it beats. Or I could draw something that looks like a raindrop and make it rain. This is the kind of magic where we recognize a gesture, a drawing, and we'd like to deep dive into this. So this activity is based upon a pretty cool paper from the University of Washington, from Warburg, Wilson, and Lee, called the $1 gesture recognizer. And what we're doing is a simplified version of that algorithm, just the bare necessity to get it to work. And we're going to start from nothing in Snap. So the first thing we'd like to do is actually make a part that lets us draw single gesture shapes, single strokes. So we want to make a little sketching, a little drawing program. I'm going to the stage and I want the drawing to start whenever I click the mouse. So instead of clicking on the stage, I want it to be whenever I'm pressing the mouse button. And I want the thing that's happening not to happen on the stage, but I want it to happen on the part of a sprite. So I'm going to broadcast a event. And so I want to start sketching. So I'm broadcasting the event sketch. Now I'm switching over to the sprite, and I want the sprite to react to the sketch event. So I'm going to say when I receive sketch. So what should happen is I wanted to clear the stage, and I wanted to repeat until the mouse button is no longer pressed. So repeat until the mouse is no longer down. Now it's very simple. We just wanted to go to the mouse position, to the mouse pointer, and we want to put the pen down. I'm doing it at every step, so I don't have to be careful when it starts and when it stops drawing. And when I'm done, I can lift the mouse up again. Let's try this. Let's draw hard. Yes, this works. I'm still seeing the sprite, so what I can do is I can hide the sprite, and I can make the pen size a little bigger. I'm going to set the pen size to 3. Let's try to draw a house. Yes, this works. Now I can draw single gesture strokes. Here it'd be a star, for example. Now, this is easy, right? So how can we animate this? Now, in order to animate something, we have the pen trails reporter that gives us a costume of the pen trails. And what we can do is we can let the sprite wear the pen trails as a costume. So in order to do this, first, we'd let the sprite again go to the center of the screen, point to the right, and then we're going to switch to the costume of the pen trails, and then we can clear the pen trails. And now, as it's already hidden, we want to again show the sprite. So now we're showing it again. So now we have a sprite that is of the picture that we just drew, and now we can animate it. For example, if it's a star, we could say, okay, we want it to blink 3 times. So blinking means we just want it to hide and show with a little pause in between. Let's put the pause like 0.3 seconds. So this would be our animation. Let's click on this to check it out. Yes, the star is blinking. And afterwards, we want to restore the pen trails like they were before. So we can again go to the center, point to the right, and to restore the pen trails, we're just going to stamp them, and then we can again hide the sprite. So let's put this all together. This is a little script that makes a star blink. I'm clicking on it, and it doesn't blink. Try this again. A star. Going to the center, switching pen trails. The star is blinking and it is restoring its shape again. Now I'm going to draw a heart, and that heart can also blink, but I want to make that heart throb. I want to make a heartbeat. So what I could do is I could just duplicate the script I've just written, and it's really just this part in the middle that is going to be different. So here, instead of hiding and showing it, I want to grow it. So I can say repeat 10 times, change the size by 10, and then set it to 100% again. Let's stick this together and try this. So now I've got a heartbeat. And you can already see that these two scripts are kind of the same, except for the middle part. And so this middle part is the part that has the actual animation. So whenever we're noticing kind of repetitive stacks of blocks, we can turn this into its own block. So I'm going to make a new block. It's going to be of the looks category. It's going to be a command block, and it's going to say animate the shape, and I want to give it an action as an input. So I'm going to mark the action as an input, and I want the action to be something, the stack of block that I can put into the C-shaped input slot. So I'm going to make the action a C-shaped input slot. I'm going to apply it. We already see this block here, so I can wrap this around. Now what I need to do is the stuff that comes before, I'm just going to drag it into. So this initializes the sprite to animate something. Then I want to do the actual animation using the run block. This is the part where I'm going to run the action. And afterwards, I want to restore the status quo again. So I'm going to add this afterwards. this is our little animation block. We can now also throw this one away and use our same animate block also around this other script that makes a heartbeat. Let's try this. This is my heartbeat. So I can label this action heart. I'm going to make when I receive the event heart, it is going to beat. And this animation is blinking. This is what I want to happen when a star is drawn. So I'm going to make this the event star. This little trick that we can make a block that runs an arbitrary other script is actually a cool thing. It's a higher order function. It's even a control structure. And it's one of the really fun and powerful things that we have in Snap. So now we've just made a little drawing program and we've made a mechanism that lets us animate whatever we've drawn. Now, how cool would it be if our program could actually recognize what we drew to decide whether it is a heart or a star? In order to let the computer learn this, we'd have to record some data. So I'm going to make a variable, and the variable is going to be the data of what I'm drawing. I'm going to call it sketch. I'm going to initialize the sketch to be a new list. So whenever I draw something, at every step, I'm going to add the coordinates to that sketch. So this is going to be a list of the X and Y coordinates of my sprite that is drawn. So now let me draw a star. And you can see there the list is growing, and it's a pretty long list, 154 points. So now I have a bunch of points, and it'll be interesting to actually see and visualize these points to see where they have been recorded. So I'm going to make another little block that shows this. This block is going to be in the pen category. It's going to be render a path. A path is a list of coordinates, and path is going to be an input. It's going to be a list of coordinates, and this should draw something. So first I'm going to clear the stage, and then I'm going to use the for each loop, and I'm going to iterate over the items in the path. These items are actually points. So for every point in the path, I'm going to make the sprite again go to each point. And a point is a 2-item list. We can use these directly in the go-to command. Then again, I'm just going to do the same thing. We're going to do the pen down, and when I'm done, I'm going to lift the pen up again. I'm going to apply this and try this now. Here's our render block. So I already have the sketch block. Let's try this. So if I click on this, it is again rendering the star pretty much exactly like I drew it. Now I want to visualize every point that's in the path. So what I'm going to do is I'm going to set the pen size to 1. When the pen is down, I'm going to set the pen size to 3. I'm going to move just a little bit. Actually, I don't have to move at all to make a little dot. Then I'm going to reset the pen size to 1. And I also want to do this very quickly. I just want to do this in one frame, which is where I'm going to use the warp block and warp it around the loop to make this all happen in one step. So this little render procedure now will show me the distribution of the blocks in my sketch. I'm going to click it, and you can see at the edges where I'm drawing less fast, the blocks are more closely to each other. I'm actually going to make these a little bigger, make these 5, and now I'm going to draw like a heart. I'm going to start slow, now it's fast, slow again, fast. I need to adjust something, and this is where my points are now distributed. And so now an idea is to abstract the shapes that we found. Abstract in a way that we can compare them to other shapes and find out how different they are. And so the first thing that we'd like to do is to resample this shape so that there's all of these shapes that we draw have the exact same number of dots, of points, and that they are evenly distributed. So the first thing we need to find out is the length of this whole path, and the length of a path is the sum of all individual segments. So we need to find out the distance from one point to another point. For this, I'm going to make a function, a reporter block in the sensing category. I'm going to make a new block. It's going to be a reporter block, and it's going to say distance from point 1 to point 2. So I'm going to make point 1 an input. This is a point. It's a list of 2 items, an x and y value. And as is p2, point 2 also is a list input of 2 items. So what is the formula to finding out the distance between 2 points? Well, you can look that up on Wikipedia as the Pythagoras Formula. So we want to have the x value of one point minus the x coordinate of the other. Then we want to square it and add it to the difference of the y coordinates, and then take the square root of it all. So it's the square root of the sum of the square of, now we take the item 1 of our second point minus the item 1, which is the x coordinate of the first point. And we want to do the same thing for the y coordinates, so we can just duplicate that whole part and put it into here. So this is the Pythagorean theorem. This will give us the distance of 2 points. I'm going to apply this and actually try this. Let's test this out. Here now is my new block. I'm going to take this list and make a list of 2. Let's start at the origin and see what is the distance to, what if I just go 5 steps to the right? I would hope the distance is 5, and it's not. Oh, this is because, see, here I forgot to change it to the item 2. So let's apply this. So let's try this again. It should be 5. Great. Let's try the other way around. So now I'm just going 5 steps up. The distance is also 5. What if I go 5 in every dimension? 5, that's roughly, I would assume something like 7. And is something like 7. So this is my distance from one point to another point reporter. This works. We can now remove this again. So now I've found out how to compute each of these segments. So now I want to make another reporter that gives me the length of all of them. So I'm going to make something that says length of path, and I need a path as an input. So the input path again is my whole shape. It's a list of coordinates. And this now should be just a simple loop. So I'm going to meet a variable one for the result, which is going to be the length. And also want to keep track of the last point. I'm going to initialize the last point. I'm going to start with the first one. This is the first item of the path. And then I want to, loop over all the points. Over each point in the path, I want to change the length by the distance from the point I'm at right now to the last point. Then I want to remember that last point by setting the last point to whichever point I'm at. And I want to do this all in one step. Remember, that's what warp is for, so it goes very fast. And when I'm done, I want to return the sum, the length that has been accumulated. Let's actually try this. So I have the sketch here. I want to find out the total length of this, length of this whole path. And it's 730. That seems about right for a shape on the snap stage. So now that I have the whole length and the distance between 2 points, I would like to write a function that equally distributes these points. I'm going to call this function resample. It's also going to be in the looks category. It's going to be another reporter. Resample is going to be path to a number of points. So the path is going to be an input. That's going to be my shape. It's a list of coordinates. And the number of points is a number. And that $1 gesture recognizer paper, they're using 64 numbers. I'm going to use that number as a default input. And in order to accomplish this, I also need to start with a bunch of variables. So at one point, I want to return the samples, a new list of 64 points. I'm also going to want to compute the step, that is kind of the spacing in between the points. I want to record the last point. I want to find out the distance between the points. And I need to keep track of what's left of the rest that I need to move before I'm going to interpolate another point. So I'm going to initialize again my last point to the first item of the path. And I'm going to initialize the samples to be a new list. And I might as well just add the first one to it. And then I want to again enumerate all the points in the path. So I also want to space these evenly. So I want to find out the step, that the distance between each of these points. So I'm going to set that step to be the quotient of the total length of the path divided by not really the points, because if we have 2 points, we just have 1 segment. If we have 3 points, we have 2 segments. So it's really the number of points minus 1. That's our segment length. That's our step. So now what we're going to do for each of these points in the path, we want to do something And then again, we want to not forget to afterwards to set the last point to whichever, oh wait, mistyped to be the last point. So now we want to find out the distance. We're going to set the distance. That's going to be the distance from the point we're at to the last one. And we want to change the rest. We still need to do by that distance. Now we need to interpolate what's in between. So we're going to repeat until what's left is less than the step we need to take. And for this, we're going to change the rest. We're going to subtract, so we're going to change it by the negative of the step. Now we're at a point where we can actually add a coordinate, and we're going to interpolate it. So we're going to add something to the samples. And what we're going to add is we're going to take the ratio of what's left or rest to the distance between the 2 points and apply it. So we're going to multiply it to the difference of the 2 points. Now this is something where we'd have to usually do x2 minus x1, y2 minus y1. In Snap, we can do this all in one step. We can just subtract vectors and subtract points from each other. So we're going to use this in between these 2 points. So we're going to have this point minus the last point. And now we want to subtract that from the current point where we add. This is our interpolated point. We're going to add this to the samples. And since we also want to do this very fast, we're going to wrap a warp block around all of this. When we're done with all of this, we want to add the last block in case it didn't get added already. So we're going to add the last item of the path to the samples. And we could just return the samples now, but sometimes there are edge cases where, you know, one additional point might get added, and then it's difficult to find out and to compare these two shapes. So we want to make double sure that we're only returning the number of points that we're asking for. So we can say we want to get the item, not the item 1 of the samples, but we want to get all the numbers from 1 to the specified points of the samples. So I'm going to apply this. This is my resample function. I'm going to try this out now. Go to looks. Here's my resample function. Here's my sketch. The sketch is 232 points. And now I'm going to resample it to 64 points. You can see it's 64 points now. Now I want to render. This is my sketch as it is. Now I want to resample it, resample the heart to these 64. I'm going to click on this, and we can see they are now evenly distributed. And see, this is fun. We can change this. What if we just take half the dots? So now it's less. You can see it's getting more edgy, but it's still very much discernible as being a heart. What if we're having it again? What about 16? It's still looking like a heart, and this is kind of interesting. How about 8 points? Now it's starting no longer to look like a heart, but it's actually interesting to see with kind of what's the least number of points we need so we can actually distinguish a shape. So I'm finding that for these single gestures, like 20 points is actually a lot. So 64, we're kind of on the safe side to render something. This is our resample procedure. Resample is really cool, folks, because what we can do, let me just put this on here. Resample is something you can use, for example, when you use turtle stitch to stitch something, a design that you made, to make sure that the stitches are all at the same size. So it doesn't matter whether you draw something fast or not, whether you take a long time, it will just give you the number of points that you specified, and you can play with that. So now that we can do something like this, we can say, okay, this is a heart. Let's try to actually teach our program how to distinguish a heart from a star. So this is something I just drew. It's obviously a heart. So I want to let this be an example of a heart. I want to say, hey, program, let me show you what a heart looks like. So I'm going to make another variable. I'm going to call it examples. And the examples is going to be a list. Setting the examples to be a new list. And I want to add what I just drew as an example of a heart. So I'm adding a new list to examples. It's going to be a table. And the list is going to have this resampled version. I want all of the examples to have exactly the same number of points. So this is what I just drew, the resampled version. And I want to tag it. I want to give it a name. The name is going to be, this is an example of a heart. Okay, I'm going to click on this. Now I've got a shape as an example of a tag, a heart. I can now throw this initialization block away and draw something else. Let me draw an example of a star. So now this is an example of a star. I'm going to say, okay, I'm going to add this as an example as a star. So I'm adding this. And now you can see now my examples file, kind of my examples table, has two items, one example of a heart and one example of a star. So now the trick is, I want to make it so that when I draw something, that it determines which of these examples it is the most similar to. It's highly unlikely that the next time I'm going to draw a star, let's draw it now, that is going to be the exact same thing that I drew before, that every point is exactly like the one that I drew in the example. So I want a way to find out the difference between one shape and another shape. So let's make another function in sensing that determines the difference between one shape and another shape. I'm going to make a new reporter. It's going to be called difference between a shape 1 and a shape 2. So shape 1 and shape 2 are going to be inputs. They're going to be paths of coordinates. And this is kind of similar to what we've done before. Let me again make a variable. It's going to be the difference. And I'm going to assume that both of these shapes are going to have the same number of points. So I can use a for loop. I'm going to say for 1 until the length of my shape 1 I want to change the difference by, you guessed it, the distance of item I of my first shape to the item I of my second shape. And again, I want this to be very fast, so I'm going to wrap the warp block around it. And when I'm done, I want to report that difference. This little procedure, this little function, lets me compare the accumulated distance between the corresponding points of two resampled gestures. Now I should be able to find out which of my examples has the least distance, is least different to what I've just drawn. So I'm going to make a function, and this is going to be the crowning function of this. This is going to say recognize. Recognize a drawing and a set of examples. Find out the one example that it's closest to. Drawing again is a list of coordinates, and the examples is a list of examples. So in order to find out the one, I'm going to have a bunch of variables. I need the difference. I want to keep track of the minimum difference. And eventually I want to find a match. So I'm going to say for each candidate in my examples, I want to find out the difference. And say the difference is going to be the difference between not just my drawing, because that might contain any number of points, but between my resampled drawing. So I'm going to resample that drawing to the candidate. But remember, the candidate itself is a list where the first item is the example and the second item is the tag, the name. So I want to compare it to the first item of the candidate, which is the actual shape. So now I have a number. I have the difference. And now I can check whether that is the minimal difference. So I can check whether that difference is less than the minimum, because if it is, I have a match. Because it is, now my match is the candidate, and I'm going to keep track of the new minimum. And afterwards, I can report just the name of the candidate, which is the second item of my match. Now the only thing I need to do is, since minimum is initialized with 0, I need to find out the first item. So at first my match isn't anything. So I can find out whether match is a list, then I already have a match. If it's not a list, I still wanted to qualify. So I'm going to say if it's either the new minimum or if it's the first thing in my test. This is my recognize function. Let's actually try this. So here I've drawn something. I've drawn a star. I'm going to recognize the sketch. This is my sketch. I want to recognize that in my examples and find out which one it closely resembles. And it says it's a star. So let's draw something else. My other example, which is the heart. And also remember that this is not exactly the heart that is in my examples, but just something that I've drawn freehand. Let's see whether it works. And it works. So now I have a function that can find the one that whatever I draw more closely resembles. And what I can do is I can use this as an event. So I can broadcast what I've drawn, and then I should be able to now have my other scripts react to that. Let's try this with the heart. So it finds out it's a heart, and the heart is beating. And we can say, okay, what is this? This is the star. And it does something else. So this is fun, right? So now we already have two examples. Now we can try storytelling. Let me draw something else. Let me draw a propeller. This is my propeller. And I want my propeller to turn. Oh, but look, it's recognizing my propeller as a star because it is closer to the star example than to the heart example. So I want to register this as a new example. So I can say this, I'm going to add it as an example of a propeller. So I'm going to add this to the propeller, to the list of examples. Now I'm having another entry for propeller. And guess what? I can make a new script that reacts to propeller. And what this should do is it should just rotate. So we're going to make it rotate a lot. So let's try this again. Here's my star. And it's blinking. Let's try a propeller. And it is turning. And my favorite example, the heart, it is beating. Folks, you can imagine what you can use artificial intelligence and machine learning for. You can now use this for storytelling. You can use this to control a game. You can use this just to have fun. This is an example of a supervised learning algorithm that finds a match, finds the so-called nearest neighbor from a set of exemplars of examples. This is also going to be part of a new curriculum that we're currently working on to bring AI and machine learning to schools. And we're going to give you all these blocks. So you just have to kind of work on the recognizing algorithm. You don't have to do resampling yourself, but I wanted to take the opportunity to actually show you that it's not so difficult to build this from nothing in Snap. So I hope you enjoy this, and if you have some time at your hands, why don't you try it yourself and let me know whether it worked for you or kind of the difficulties you encountered with this. Thank you very much for watching. See you around.